Hello everyone, welcome to GTQ, a short course gate through questions for this upcoming gate examination, GATE 2024. Very few days are left and I strongly believe that you all might have completed your preparation by this time and you must be in the revision mode. You might have completed all the classroom questions, all the theories. You might have revised the theory completely, first of all. And you might have practiced all the classroom questions and workbook questions, made easy classroom workbook. And you might have gone through at least 10 years of PYQs, as well as you might have attended test series, made easy test series. By this time, you should have done all these things. If you are left with any of the tests, finish them fast. This must be your preparation strategy. You must have done it by this time. And you must be simply revising as we are approaching the exam. In hardly 2 weeks' time, we are going to face the exam. So at this point of time, I would like to take this very short course, hardly a 2 hours discussion we will have, get through questions. In this, we're going to select questions from almost all the topics, some of the most important thought-provoking questions that can remind you about the concept. And I would like to solve in all possible ways, easy way and the conventional way of doing. Conventional not in the sense of the lengthy solutions. I mean to say the strategy that we try to adapt to solve a question that is formula based. And there are other ways of logical way of thinking to answer to the question, making use of the multiple choice options, multiple choice that are given to answer to the question quickly. So wherever possible, I try my best to show you an easy way and quick way of solving these questions. That's what we actually wanted at this time. So I hope that this is definitely going to help you to add a bit more to your preparation and to help you to score better. So let's get into this. In this question, what the question says, transfer function of a plant h of s, this plant h of s is denoted to be, is 100 upon s plus 10 square. The plant is placed in a unity negative feedback configuration as shown in the figure. The question is, the signal flow graph that does not model the plant transfer function h of s is. See, the question is not about this entire diagram. It's not about this entire diagram. No. Like, we think that we are talking about this closed loop, though it's a confusion that arises. We are given with a closed loop system and we are trying to find the closed loop transfer function and the signal flow graph. No, the question clearly says that it is only about this plant h of s and which of this signal flow graph does not model the plant transfer function h of s. Fine. 100 upon s into s plus 10 square. See, actually the processor, like almost all the students, they think in this way. If we are given with the signal flow graph and if we are asked to obtain the transfer function, then we use Mason's formula by verifying whether the signal flow graph given has input and output nodes or not. And if any of these nodes are missing, either input node is missing or output node is missing or both the nodes are missing, then we try to create those nodes. We know how to create the input and output nodes. And then we use the Mason formula to obtain the required ratio. But this question is exactly reverse. We are given with a ratio of output and input, that's called transfer function of a plant. And we are asked to verify that which of these signal flow graphs does not represent this plant function. So what is the general strategy that we think of? Then, sir, we have to take each and one by one option. Like we will take option A because there is no direct way to answer to this. To find transfer function, we have a direct method called Mason formula. And to find the signal flow graph, and we can do the other way. Say, given is the transfer function, we can rationalize this with the highest power of s. We can decompose this into the form of a signal flow graph. And that, like we create state diagram. There is a procedure called direct method of obtaining state diagram. These are actually state diagrams. Any signal flow graph which consists of at least one integrator becomes a state diagram. any block diagram that consists of at least one integrator, that becomes state diagram. So these are basically state diagrams. So you can use the direct method of obtaining the state diagram and then you can verify. But there is a big problem here. There are three methods to obtain state diagram: direct method, series method, and parallel method. So we really don't know which method is used to obtain this state diagram and which exact form shape we get, because direct method may take us to this, series method may take us to this. So we have to try with everyone because it is MCQ. Only one of them is not going to model. Try to understand. Out of 4 options, one option is not going to be this transfer function, that is 100 upon s into s plus 10 square. So we cannot even try this way. Suppose if I use direct method, I may be getting this as the answer. If I use parallel method, I may be getting this as the answer. Series method, I'll be getting this as the answer. So we get confused with that method. It takes lengthy. Let us try this way, sir. Take option A, apply Mason formula, find the transfer function. And if it gives this transfer function, then that is not the answer. Then try with option B, try with option C. What if the answer is option D? You have applied Mason formula 4 times in this question, and to find the transfer function every time and then verify with the given transfer function. This is going to be really lengthy way. And if it is a 1 mark question, then we really stand nowhere. So, you while learning, will learn in this manner, like professional way of learning this. We have to learn things professionally. We must know how to use Mason formula, how to apply Mason formula to find the ratio. But when it comes to question, particularly such questions where a question is flipped, it's not that you have to find the transfer function, you have to find the signal flow graph. Then you have to be a bit logical. What is that, sir? Pay attention. S plus 10 ka square. S plus 10 square, it may be either one loop or it may be product of 2 loops. S plus 10 square, it may be S plus 10 into S plus 10, or it may be one single loop of this gain. What is S plus 10 square? It is S square plus 20S plus 100. You understand? S plus 10 square is S square plus 20S plus 100. S square plus 20S plus 100. So you may think of S plus 10 multiplied by S plus 10, that is S plus 10 square, or it is S square plus 20S plus 10, which can be something like S square by 100 plus, just a second, plus 20 S by 100 plus 1. I'm sorry. Give me just a second, please. Okay. Somewhat like this. I mean, I'm talking about a time constant form with an 100 multiplier outside. Need your attention. I mean, it's a way of doing things directly without putting much efforts. Say this. This is one loop gain, 10 by S. 10 by S. It is in time constant form. Because what is Mason formula? Pk delta k by delta. What is delta? 1 minus sum of all individual loop gains. So 1 minus this minus 10 by S. That becomes S plus 10. That's what I'm saying. This is S plus 10 into S plus 10. This will become S plus 10 square. So this signal flow graph can give you this transfer function. Hence, this cannot be the answer because we have to find the one does not represent that. What about this signal flow graph? See, we have 2 loops. One is of the loop S square by 100. S square by 100. Another is of the loop 20 by S. So S square by 100 or 20 by S. What terms to dikh rahe hain? 1 plus that. So even this will give you the transfer function. So that is not the answer. Same is the story here. This has one loop of gain S square by 100. The other is of the loop 20 by s. This 100 will cancel out this, this multiplier 100. So 1 minus of this, it will become this loop and this loop, they can be seen because 1 minus sum of all individual loop gains. So this will also give you this transfer function. Answer is this. This is the signal flow graph that will not give you the transfer function. See, to explain it took time, but to answer, once you understand, it hardly takes 5 seconds of the time. In 5 seconds, you can finish this question. Whereas if you go conventionally, then we stand nowhere. It's going to take hardly, it is going to take at least 4 or 5 minutes for you because you have to try with each and every option. So what this is going to become, this is going to become s square by 100. So s square by 100, this term you can create. But how do you create this s term? There is no chance to get that s term. So this loop cannot be formed, this function cannot be formed by this signal flow graph. Answer to the question is option D. Right? So that should be easy. In this question, for the following system, when x1 is 0, find the transfer function y by x2. When x1 is 0, question is to find y by x2. Two transfer functions can be formed. Two transfer functions can be formed. One is y by x1, the other is y by x2, and we are asked to find y by x2 with x1 being 0. See, again, two ways to solve this question. Since it's a block diagram, you can use the block diagram strategy, like with x1 0 and take x2 and rewrite this block diagram like this. x2 being the input, x2 being the input. This will be the forward path transfer function, the plant. This is the output. And feedback is from output back to input. So negative feedback, because we have a minus sign here, negative feedback of value s upon s plus 1. Now this block diagram is in the form of standard closed loop topology. You have to be careful with the signs. You be very careful with the signs. Any small mistake, things are gone. So this we call it to be G. This we call it to be H, negative feedback. You can say that y by x2 is G upon 1 plus GH. You can try this way. Alternately, what you can do, though it's a simple diagram, but even if it is any bigger diagram, you can use this alternate method. You can directly apply Mason formula. No need to work block diagram as a block diagram. You can treat this to be a signal flow graph without changing this into signal flow graph. Option, apply Mason formula directly. How, sir? We have one forward path whose gain is 1 by s. There is one forward path whose gain 1 upon s. There is one loop. We know what is called forward path. The path that starts at the input node, ends at the output node without repeating any node. A loop is a closed path that starts and ends at the same node without repeating any node. So starting from here, s by s plus 1 into 1 by s minus. So negative gain minus 1 by s plus 1. Because s and 1 by s, they get cancelled. So we have got only one loop. And this loop is touching to this forward path. So determinant of the forward path is 1 minus 0. And determinant of the loop is 1 minus of minus 1 by s plus 1. So what is the transfer function? P1 delta 1 by delta. 1 by s into 1 minus 0 upon 1 plus 1 by s plus 1. So this becomes s plus 1 upon s into s plus 2. Answer to the question is option D. Option D. In this question, R and D are two inputs. The output y of s is expected to be y is equal to g1 into R plus g2 into D, where g1 and g2 are given by what happens to the value of g1 and g2. So the thing is, y is equal to g1 into R plus g2 into D means that y by R is equal to g1 and y by D is equal to g2 is what actually the question says. So we have to find g1 and g2 values. To find y by R, similar to the previous question where we have two inputs and one output, here also we have two inputs and one output. So one method is we have to find y by R with the D is equal to 0. So with the D 0, y by R, you can find that either using Mason formula or it's a simple block diagram, you can find the answer. Otherwise, and same way, you have to find y by D also. One is y by R, the other is y by D. You have to find both of them. The other way, if you focus on the diagram, so I'm saying observe the question and observe the options carefully and closely. See, when R is equal to 0, then G is the forward path function and H and 1 are the feedbacks. Then when D is equal to 0, then also G is the forward path function, H and 1 are the feedbacks. It means that the diagram remains to be of the same forward and feedback elements, whether R is 0 or D is 0. So from this observation, we understand that G1 is equal to G2. It means y by R is equal to y by D because I see that there is no change in the structure. It is the same thing, same structure. See, first of all, we can merge these two adders into one. Two adders that are adjacent to each other can be merged into one. So we are giving two different inputs at the same station. R is a different input, D is a different input. We are applying two inputs at the same node, at the same station. So when two inputs are applied at the same station, then if one of them is 0, then there is no change for the diagram structure. Whereas in the previous question, you see the difference between these two questions. Here also we have got two different inputs. One is x1, the other is x2, but they are not applied at the same station. They are two different stations. This is station 1, this is station 2. So if x2 is 0, then y by x1, and if x1 is 0, then y by x2, they will never be equal, right? Because for this input, gain is only this much, but for this input, gain is this entire path. So two different inputs are there and applied at two different stations. Then of course, the structure will change, the diagram appearance will change. With x2 0, with x1 as the input, this is the diagram. With x1 0 and x2 as the input, this will be the diagram because they are applied at two different stations. But in this case, these two adders are one and the same. You can merge them into one. Thereby, these two inputs are at the same station. So if any one of them is 0, it doesn't matter. Y by R is equal to y by D in this case. So G1 is equal to G2. So why I'm saying this, without actually solving y by R and y by D, without actually finding G1 and G2, you can verify from the options. Always try to make use of the options to the extent possible. G1 is equal to G2. G1 is equal to G2. G1 is not equal to G2. G1 is not equal to G2. Answer cannot be C or D. Answer can be either A or B. Sometimes, if you are lucky, then one of the options will pop up out of three. Like, we are able to find 2 to be right and the remaining 2 to be wrong. In some situations, you will find 3 to be wrong and 1 to be right and you can finish the question. Right. So now, sir, how to further? Very simple. For G, H and 1 is the feedback. H plus 1 is the total feedback. H plus 1. So answer is this. Because if you take G common, H plus 1. If you take G common, H plus 1. Feedback is H plus 1. So answer is A, not B. Hope you understood. Yeah, see, you will be able to solve all these questions. I'm sure you must be able to do solve all these questions. You have prepared well. Be confident. What I'm trying to explain, and slightly a different touch of solving these questions. This question, you all might have seen. This is taken from the previous papers. Looks to be very complicated and very lengthy. And I have explained this to those students who asked this as a doubt to me during our curriculum. But for the discussion of all, those who could not get a chance to ask this question to me, if you have seen this question after class completion, in all such cases, what is the question? The system shown in figure below, there is a system, a diagram is shown below, can be reduced to the form of this shape with x, y, z being equal to what? Okay, the diagram is out of the slide. Sorry. X, y, z values. P is P, the same parameter it is. X, y, z values we have to find. So if this diagram is simplified to this form, then what will be the values of x, y, z? One way is really to simplify this diagram so that we get it to be this form and compare and find out the x, y, z. But trying to reduce a block diagram, the two of this typical structure, is an unnecessary effort. My sincere advice to you, never involve in block diagram simplification or block diagram reduction in GATE exam and engineering services prelims exam. You can take up this task only for the mains, engineering services mains. Otherwise, this is going to take a lot of time, lot of steps. Then what, sir? So one method is that I don't entertain. Second method, see, you can use Mason's formula in this diagram. I mean, obviously, this is the input, right? Let us say that the input is R and the output is C, though they are not labeled. R is the input, C is the output. You can use Mason formula, find C by R. And that will become an finished, that will be in a finished form, completely compiled form, compact form. And then you also have to find the transfer function from here. That is simple. From this, C by R can be written as Yp by 1 minus Ypz into X. From here, that is very simple. But from here, you have to find the forward paths and you have to find the loops and non-touching combination, etc., etc. And then you have to come out with a transfer function. And then compare those two transfer functions to find the unknowns. Even this is also a bit time consuming. We can make it more simple by finding delta. I say that you don't go for the entire transfer function that is using Mason formula. Find delta. What is delta? 1 minus sum of all the individual loop gains plus SOP of two non-touching loop gains minus etc. So let us just focus on the loops rather than finding all the forward paths, all the loops and the loops that are not touching to that forward path. Instead of all this, let us have bare minimum amount of calculation and come out with the answer. Fine, pay attention. How many loops are there? Find out that. That should be enough. One loop is this. I want everyone to focus. Minus A1 by S is one loop. Another loop is this. Minus A0 by S square. I'll write the gains here. One loop is minus A1 by S. Another loop is minus A0 by S square. Don't start from here for the loops. If you are starting from this point, that will be to hunt the forward paths. Because for it to be a loop, it should be a closed path. So in this diagram, don't start from here for the loops because you will never be able to reach to that point back. A loop is a closed path which starts and ends at the same node. So if you start from this node, you will never be able to come back to that node because that's totally isolated, right? You can see from here, you can say that this is B0. No, go like this. B0 by S square into P. That is one loop. Another loop. Third loop is this. B naught P by S square. And fourth loop is this thing. Starting from this node. B1 by S into P. B1 P by S. This is fourth loop. 4 loops. And there is no non-touching combination because this particular node is common in every loop. So there is no combination of non-touching. So what is delta? It is 1 minus A1 by S minus A naught by S square plus B naught P by S square plus B1 P by S. This is delta. That should be equal to 1 minus YPZ. This should be equal to 1 minus YPZ. P is P. Y and Z. Now we just have to see which two options, which two YZ from the given options will satisfy this. Substitute and see. YZ. So let us not focus on X. Y into Z, we have to try with this. Y into Z. Y into Z. So if you try that product of Y and Z, if you obtain, and 1 minus YPZ should be equal to this. That is going to result into option D. Upon verification, this Y into Z will get you this answer. See, product of this and this. P is there everywhere. Let's not worry about that. In this question, signal flow graph of a system is given. This is the last question about the block diagram and signal flow graph. We'll move to the next possible topic of discussion. The transfer function y by u1. See, like in block diagrams, in signal flow graph also, we can use this Mason formula very much. We have two inputs, u1 and u2. But these two inputs are applied at two different stations. So the structure will change, the forward path gain will change if any one among them is taken to be 0. So we have to find y by u1. That means u2 0. So y by u1. Two ways to solve this question. One method is, it's a feedback structure. See, this 1 by L into 1 by S, that is 1 by LS. 1 by LS. Otherwise, we actually don't do the simplification of signal flow graph, but if it is a structure like this, it can be done easily. When there are too many number of loops and too many number of forward paths, we don't think of simplifying the signal flow graph. There is no concept called simplification of signal flow graph. But if it is in standard structures like this, it can still be done. So this is 1 by LS into R. Minus R by LS is the loop gain, right? It's like this. Loop gain in Mason formula. Otherwise, this is forward path, this is feedback path. So for 1 by LS, this minus R is in feedback, 1 plus 1 by LS into R, G by 1 plus GH. So this structure can be replaced with this result. For that, K1, 1 by J, 1 by S, they are in series. So multiply this with K1, 1 by J and 1 by S. So that becomes one forward path completely. For that, this is in feedback. You can even do like this. I mean, if you're not willing to, if you don't want to apply Mason formula, you can surely do like this. This is not using Mason formula, okay? This is in feedback structure. Use this formula. For that, these three are in series. Multiply. For that, this is in feedback upon 1 plus that into K2. You can even solve it like this. Otherwise, use Mason's formula. We have got one forward path and we have got two loops. this is one loop, and this is another loop. And these two are touching with each other. You can use the Mason formula to find the transfer function even in that manner. So, usually signal flow graph does not, we don't deal with reduction principle, but also have it in mind. If possible in some simple structures, then it is definitely allowed to do the simplification there. You can do this and see. Answer to this question comes out to be option A after calculation. Take up this question. In this, a control system with a PD controller is shown in the figure. If the velocity error constant Kv is 1000 and the damping ratio zeta is 0.5, then find the values of Kp and Kd. It's a PD controller and a second order plant. P plus D controller in series with a plant. Question is to find the value of Kp and Kd for this velocity error constant and damping ratio zeta. One way to solve this question is writing all the relevant equations, characteristic equations, steady state formulas, and then find the answer. The other way, answering this conceptually. First, let me explain things conceptually. Steady state error of this system, type 1 system, for ramp input, velocity input, right? It is 1 by Kv, where Kv of the system is 10, 1 by 10, this is 0.1. But this PD controller is used to have a velocity error constant of 1 by 1000. It means PD controller is used to have a steady state error of 1 by 1000. 1 by Kv, Kv has to be 1000. So presently Kv is 10. With the help of a PD controller, we have to improve this Kv, velocity error constant, to 1000 so that the steady state error gets reduced by 100 times. Remember, PD controller will act as a proportional controller in the steady state, and it acts as a derivative controller in the transient state. So PD controller improves the transient response characteristics completely and perfectly, whereas it also improves the steady state characteristics, but limitedly, right? Transient response parameters can be improved perfectly, completely perfectly. All the parameters can be improved, and they can be improved to the extent that we want. We can even eliminate overshoot. To that extent, transient characteristics can be improved using PD controller. But we can also improve the steady state characteristics of a system, but it is not possible to eliminate the steady state error. We can reduce it to the extent that we wish to, but not elimination. It means we can't make it zero. So present steady state error has to be reduced by 100 times. How we can do that? PD controller acts as a proportional controller. So whatever steady state error we have without PD controller, that gets divided by Kp. That gets divided by Kp upon using proportional or proportional plus derivative. If I use proportional controller, or if I use proportional plus derivative controller, whatever steady state error we had earlier, that gets reduced by a factor Kp. Whereas if I use integral controller, or proportional plus integral controller, or proportional plus integral plus derivative controller, then the steady state error will become 0. From finite value, it becomes 0. If I use a derivative controller, then that steady state error is going to increase by Kd value. Remember all this? Proportional and proportional plus derivative. They will reduce the steady state error by Kp times. Derivative controller increases the steady state error by Kd units, whereas all other controllers will make the steady state error 0. This is the conclusion of the controllers about steady state error. Fine. So this has to be how much? 1 by 1000. So very simple, Kp has to be 100, that's all. Kp times steady state error reduces. Steady state error has to reduce by 100 times. So Kp is 100, straight answer. I mean, if you're lucky, you will end up with one answer. But I mean, we have two options in which Kp is becoming 100. Now we are forced to solve Kd. Even that can be solved conceptually. I'm trying to remind you about the concept. That's why it is taking time. But it really won't take time to solve. If you're thorough with these concepts, if you're thinking the way that I'm thinking, it is a matter of seconds to finish these questions. And if you're lucky, the question would have finished by this time. If this Kp is something like other than 100, then answer would have been A. But we still have to continuously hunt for the options. Kd kaise karenge, sir? See, what happens in case of PD controller, it is going to reduce the steady state error by Kp times. At the same, in case of proportional controller, steady state error reduced it by Kp. Whereas zeta will also be reduced by the factor root Kp, because proportional controller increases omega n and reduces zeta in the process of reducing steady state error. That's why we use proportional plus derivative controller, where we can use P part of the controller to reduce the steady state error and D part of the controller to maintain the zeta or to improve the zeta. We can do either way. Either we want to maintain the zeta or we want to improve it further. See, without this PD controller, you know, what is the zeta of the system? S square plus 10s plus 100 is equal to 0 is the characteristic equation. Omega n is 10, zeta of the system is 0.5 without proportional controller, without proportional plus derivative controller. Now, if I don't use this derivative part, if I use only proportional part, then what happens? Still the steady state error can be reduced by Kp times, and I can achieve this thing. But this thing will get affected. Without proportional controller, Kv is 10, steady state error is 0.1. With proportional controller of gain 100, now Kv is 1000 and steady state error is 0.001. But without proportional controller, zeta 0.5. With the proportional controller, that zeta is not 0.5, that is 0.05. बहुत ज़्यादा reduce हो गया वो. Okay, because it has increased omega n, right? So now new omega n will be 100. 2 zeta omega n is 10. Zeta 1 by 20.05. Zeta got reduced by 10 times. So remember, if you memorize, it makes you easy. If you use proportional controller, you know what happens? Steady state error reduces by Kp times, omega n increases by root Kp times, and zeta reduces by root Kp times. But here we have to have a zeta 0.5, which was same as the old zeta. So ये जो zeta 0.5 से 0.05 जो हो गया ना, sir, how can I restore it back to 0.5 with the help of an additional derivative controller? That's what P plus D for you. So we need to have a derivative controller now in order to improve the zeta from 0.5 to the new value, 0.05 to the new value. So what happens? Zeta new will be zeta old plus Kd omega n by 2 is the formula now. We did all this analysis. What for? To remember the end results and to get the answer quickly. We don't want to have the professional way of solving things. We learned that way, but we don't want to execute those ways. If I have a strong concept and I can quickly solve this question. So new zeta, this has to be 0.5. Old zeta, it means this one now. Because with the proportional controller of Kp 100, I have a zeta of 0.05. This has to be restored to what value? 0.5. So if you solve this with, the old zeta is 0.05 plus Kd omega n, but if you work out, you're going to get this Kd to be 0.9. You will get Kd to be 0.9. Sir, I don't remember all these things. Then what to do? You have to form the closed loop transfer function. You have to obtain the characteristic equation from that, which will have Kp and Kd. and then you have to use the formula of the steady state, or you have to use omega, and you have to find zeta, and then you have to go for all these calculations. That way also you can do. May take little extra time, but this way you can be quick if you remember the concepts. In this question, for the following feedback system, G of S, that is 1 upon S plus 1 S plus 2, the 2% settling time of the step response is required to be less than 2 seconds. Settling time of this closed loop system, not only of the G of S. G of S is just a plant, it's an open loop system. The closed loop system needs to have a settling time less than 2 seconds for 2% tolerance. What does it mean? This system does not have 2 seconds of settling time. That's what it means. It has more than that. And we want to make it to be less than 2 seconds. Which of the controllers is recommended? If you are not strong conceptually, if you depend only on the formulas and calculations, if your approach to solve the question is only calculations and the formula, then you know what you have to do. See, these are all reverse questions. You know, one question is, you are given with the transfer function, find settling time. And it's a direct question. Sir, I have got the transfer function of a system and I'm asked to find the settling time for 2% tolerance. Anybody will do that. No, it's a reverse thing. You have got the transfer function and it has got some different settling time, and you need to reduce the settling time below a certain value. Which of the controllers or compensators will help you with that? So as far as the calculations are concerned, you know what you have to do. You have to use each of this controller in this place. Take this plant, 1 upon S plus 1 into S plus 2, along with this controller. Form the closed loop transfer function. You will get a transfer function. Then you find the settling time of that new transfer function. And if that is becoming less than 2 seconds, then answer is A. Otherwise, you have to try with option B. If not, you have to try with option C. Otherwise, you have to go with finally option D. So you have to try exhaustively till you get the correct answer. ये calculation तरीका और formula based तरीका. Let's not do that. Be conceptual. Option A, it's a pole. Pole provides negative phase. Negative phase means lag phase. Lag phase means time delay. It means if you use this as a controller or a compensator, then whatever is the settling time of this, that is going to be increased beyond that. That becomes more. We are trying to reduce it, but this will make it more. No way applicable. Option B, it's a PI controller. Proportional plus integral controller. Try to understand the functionality of a PI controller. PI controller can improve the steady state response characteristics of a system completely and perfectly. It can also improve the transient characteristics of a system, but limitedly. It has got a limitation to improve the transient characteristics. PD controller has a limitation in improving the steady state characteristics. PID controller has no limitation in improving either of these characteristics. PID controller can improve the transient characteristics as well as steady state characteristics of a system completely and perfectly, no limitation, no flaw, nothing with that. So you are trying to fix the transient characteristics. So you have to be biased to a PD controller or a lead compensator. And if you are trying to fix the steady state characteristics, then you should be biased to a PI controller or a lag compensator. When it comes to both transient and steady state characteristics requirement, then you need to look for a PID controller or a lead lag compensator. That should be a strategy. Be clear. Right. When we look for a PI controller to improve the transient characteristics, all 4 options are PI. Assume that all 4 options are PI. And the question is to improve the transient characteristics. Then we choose the best PI among the 4 PI or more than 1 PI controller given in the absence of PD controller. Then we try to take the answer. You have a PD controller and you have a PI controller. We never use PI controller to improve the transient characteristics. We always choose PD, right? Unanimous, no competition. No PI controller can ever compete with a PD controller for the transient characteristics. What are transient characteristics? Delay time, rise time, peak time, setting time, peak overshoot, settling time. These are transient characteristics. Steady state characteristics means steady state error. No PD controller can compete with PI or PID controller when it comes to steady state characteristics. So you have to read the question carefully. The question is about settling time and it's a transient parameter. Hence, it's a PD controller which should be preferred. Got it? So it's a PD controller which has a 0 in the left side of a spline. You should be knowing what is called PD controller. It's a 0 in the left side, right? You should know the transfer function formats. This is lag compensator. It's a compensator, but lag compensator because pole is dominant compared to the 0. It's a lag compensator. So answer is option C. So in this question, there is no calculation needed. When we calculate, I want everybody to pay attention. I want you to understand this thing. When we do calculations, when we have two options of PD controller, let us say that, sir, option C is a PD controller, option D is a PD controller. You say that we don't take pole or lag or PI, remove them. But we have got two options of PD controllers. Now what do we do? Then we will be using each of the PD controller and we will be trying to get the transient characteristics of the system. Sometimes what happens, PD controller means it's a 0 in the left side of S-plane. But 0 in the left side will not get you the characteristics that you require. That has to be moved into the deep left side of S-plane. I want you to pay attention. We have a second order system. We have, this system has a pole at -1 and the answer to the question is over, long back. I'm trying to explain you the concept. We have two poles in the left side. This system has some settling time. Let us not worry how much it is. It is definitely greater than 2 seconds. That's why he want to bring it less than 2 seconds. And I'm looking for a PD controller. PD controller means it's a 0 in the left side of S-plane. And that 0 can be added anywhere. If the 0 is here, then also it is PD controller. 0 here is also PD controller. 0 here, that is also PD controller. PD controller means it's a 0 added into the left side of S-plane. Okay, so the 0 here added in the left side of S-plane may not be able to provide you the desired characteristics. Try to understand. Every PD controller, it means it's a 0 added in the left side of S-plane, will definitely improve the transient characteristics. But by what amount is the question? By what amount? Let us say that this system has a settling time of 3 seconds. Assume 3 seconds. If you use a PD controller, which is a 0 in the left side of S-plane, let us say that this is that 0 in the left side of S-plane, will reduce that 3 seconds from 3 to 2.8 seconds. You will get 100% improvement. But what amount is the question here? So though I say that the PD controller has improved the transient characteristics of the system, has reduced the settling time, but not by the amount that I'm looking for. From 3 seconds, I came to 2.8 seconds, but I have to go below 2 seconds. And this PD controller, a 0 at a different location, that may be able to make the settling time from 3 to 2 seconds. But still my requirement is not satisfied. I have to go below 2 seconds. Probably this 0, which is in the left side of S-plane, a PD controller, that will make the settling time as 1.5 seconds. And that means that it's a 0, that is my requirement, less than 2 seconds. So what I'm trying to say, when we have more than one PD controller, then we have to get onto the calculations. We use each of the PD controller along with this plant, and we will calculate the settling time using the formula 4 by zeta omega n, and we see which of them is going to make the settling time less than 2 seconds. So don't think that any PD controller can make the settling time less than 2 seconds. No. PD controller ensures that I can reduce the settling time from the original value. But how much is going to be the reduction, that varies from one PD controller to the other PD controller. That you should be careful with. So answer to the question is option C. This question के लिए तो 1 second काफी है. 1 second is, I think I took 5 minutes. Wait a second, please. I think I took 5 minutes of the time to explain, but I was involved into the concept so that if you face a tough question, you can still be able to answer. But that's what really not required for that. Right. So what is this question about? The unity feedback system that uses proportional plus integral controller is shown in the figure. The stability of the overall system is controlled by tuning the PI controller parameter Kp and Ki. Question is to find the maximum value of Ki that can be chosen so as to keep the overall system stable, or the worst case marginally stable, rounded up to 3 decimals. I mean, questions about PI, PD controllers. This is from the previous papers. Very, lengthy solution. Some questions, they really need time. And particularly when it is not an multiple choice question, when it is numerical data type question, then believe me, there is no way other than solving that question. In all the questions that you have gone through, I think 7 or 8 questions that we have discussed, I tried to show you some easy way of solving the question or the other. But that's not possible every time. Even if it is a multiple choice question, I say that around 50 to 60% of the questions, even to an extent of 70%, needs hardly any calculation, or they don't require calculation if you're strong with the concepts. I'm talking about control system. If you're thorough with the concepts, and if you have some logical thinking, with the help of the options given, to an extent of 70% questions can be finished. And you might have seen in the test series solutions that I have provided to you, if you have gone through MadeEasy test series, and if you have gone through the solutions provided by me, you might have seen that I would have hardly taken few seconds to answer the question. Don't miss that. Please go through the solutions. I mean, if you have not gone through, please go through my solutions of test series, MadeEasy test series. Go through the solutions. There you will find brilliant ways of solving the questions. While learning the subject, we need to have the professional ways of learning the formulas, the concepts and everything. But when it comes to solving question, you have to be very cunning. You have to be very logical, make use of the options and some hidden trail methods so that you come out of the question quickly. So that's what I say. 70% of the questions can be solved with either no calculation or bare minimum calculation. 30% of the questions, 30 to 40% of the questions, yes, they really require genuine calculation. And numerical data type question, you have no support of the options. You have to go through all the calculations and you have to get the answer. This is one such question. I'm choosing this question to tell you that not every question can be solved the way that we have been solving. Some questions, they require either you or me. No way, you have to go through all the calculations to be done. Question is about getting the stability condition, finding the maximum value of Ki to keep the system stable, or the worst case marginally stable. So we have to form the characteristic equation and we need to form the route array, and from that we need to get that condition. Let's give it a try. Characteristic equation of the system. It is 1 plus Kps plus Ki by S 2 upon S cube plus 4S square plus 5S plus 2 is equal to 0. 1 plus GH. This characteristic equation can be written as S to the power 4 plus 4S cube plus 5S square 2 plus 2Kp S plus 2Ki is equal to 0. This is the characteristic equation. Necessary condition first. All the coefficients of the characteristic equation must be present and they must have same sign. Ki greater than 0, Kp greater than -1. This is the necessary condition for stability. What about sufficient condition? That we need to form the Routh array, and from that we have to get the sufficient condition. S to the power 4, 3, 2, 1, 0. 1, 4, 5, 2 plus 2 Kp, 2 Ki, 20 minus 18 minus 2 Kp by 4, 2 Ki, then this multiplied by this, that element, and 2 Ki. I did all the calculations. Let us not waste time here for the calculations. So the condition, sufficient condition is all the elements of the first column of Routh array must have same sign and no row should become 0 completely is the condition. Based on that, we are going to get the stability condition to be -1 less than Kp less than 9 Kp value and Ki 0 less than Ki less than 36 plus 32 Kp minus 4 Kp square upon 32 is what we get from the Routh array. This is positive, this is positive, this has to be positive, this has to be positive, the same conditions. Remember, whenever we have two unknowns but one condition, one of them can be chosen independently, the other one has to be chosen based on the first one. We have two unknowns but one condition. So, one of the unknowns can be chosen independently. The other unknown has to be chosen based on the first one. Two unknowns, Kp and Ki. Condition is one, stability. So, Kp is obtained independent of Ki, but Ki cannot be obtained independently. That should be obtained based on Kp, depending on Kp. That should be the strategy. If the question says, obtain stability condition, this is the answer. If the question says, obtain the condition for this system to be stable, answer is this, we are done. Otherwise, if the question says that, various ways of asking question. If the question says that, find the value of Kp and Ki for the system to be stable. Isn't? If the question says that, find the value of Kp and Ki for the system to be stable. We have infinite number of values of Kp and correspondingly infinite number of values of Ki for the system to be stable. If in that case, it should be an MCQ. If the question says that find the values of Kp and Ki for the system to be stable, to give some specific values, it should be MCQ. Let us say that you are given with 4 options. So from those options, what you do, you have to pick that option in which Kp lies in this interval and correspondingly Ki depends on this condition. That way you will finish the question. But this is entirely different. You are asked to find the maximum value of Ki for this system to be stable. So, for some value of Kp, Ki is going to be maximum for the system to be stable. That we need to find out. Let's try like this. Let Kp be -1. Then if you find Ki, it will become 0. Substitute and see. Let Kp be 9. Then Ki becomes 0. Substitute and see. It means what? Ki is behaving like this for the values of Kp. Kp is independent. Ki is dependent. Independent variable will be on the x-axis, dependent variable will be on the y-axis. When Kp is -1, Ki is 0. When Kp is 9, Ki is 0. It means that Ki starts with 0, ends with 0, but it is maximum in between. A function which is starting with 0 and ending with 0, but not 0 in between, so it is a maxima. So for some value of Kp, Ki is maximum, and we have to find that maximum value of Ki. First, we have to find the value of Kp for which Ki is maximum, and that has to be done by dki by dkp is equal to 0. From this, you will get Kp to be 4. Correspondingly, the value of Ki maximum is going to be, after the calculations, you can substitute and get this, 3.125. 3.125. This is the solution here. What this question is about? Consider a closed loop system shown in the figure 14 with the plant function 14.4 upon s 1 plus 0.1 s, and the controller function is 1. So GC is simply 1. So what we have is entirely plant with unity feedback then. For unit step input, the output response has the damped oscillations. The damped natural frequency of the system is. We have to find the damped natural frequency of the system. One is undamped natural frequency. The other is damped frequency of oscillations. Omega n is undamped. Omega d is damped, which is omega n root 1 minus zeta square. You have to be very careful. We have two damped frequency of oscillations. Omega r, this is omega n root 1 minus 2 zeta square. This is also damped oscillations frequency. That is also damped oscillations frequency. Oh, come on. Don't, sir, isko to resonance frequency kehte hain. Resonance frequency of oscillation. Yeah, resonance frequency of oscillation is a name, but is a specific name based on the phenomenon. But the generic name is damped oscillations frequency. Medicine is one, but names are two different. Paracetamol. Paracetamol is the medicine. That's the generic name of it. But its trade name will be different. Right? Someone says it to be crocin, someone says it to be dolo and something and something. So generic medicine ka naam to paracetamol hota hai na, aise something. Right. Omega D, damped oscillations frequency. Time domain mein we have the generic name. In frequency domain, we have got a trade name called as resonance frequency of oscillation, because we find this under the phenomena of resonance. But actually, this is also damped frequency of oscillations. So should I solve this or this? The question says, find the damped natural frequency of oscillations. Both are damped frequencies. Omega n is undamped in any domain, but in time domain, damped oscillations frequency is this, and in frequency domain, damped oscillations frequency is this. So how do we know that? Which one? That's where you have to read the question very carefully. The question says that for unit step input, the unit step input, if the input is impulse or step or ramp or parabola, that's called time response analysis. And if the input is sinusoidal, then that is frequency response analysis. So a change in the word will change everything. Instead of for unit step input, if the question says that for unit sinusoidal input or for sinusoidal input, find the damped frequency of response, then you have to go by this. For step input, it is this. So whenever we have got this, by default damped frequency means omega d. But it also depends on the question. If nothing is mentioned in the question, sir, question mein kuch nahi mentioned hai. It is neither mentioned for unit step input, nor it is mentioned for unit sinusoidal input. Then, sir, what do we do? By default, it is this. Default damped oscillations frequency is omega d. But if the input is mentioned in the question, observe it very carefully. For unit step input, it will be this. For unit ramp in, for unit sinusoidal input, it will be this. Right. So now it is this thing that we have to solve. We have to find omega n and zeta. Finding the characteristic equation of the system. 1 plus gh is equal to 0. It will be 0.1 s square plus s plus 14.4 is equal to 0 is the characteristic equation. in examination tense, in the tense of examination, in hurry, we do a lot of mistakes. If the mistake is due to lack of concept, you won't regret that much compared to if the mistake happened due to the calculation mistakes. Right? Simple calculation mistakes, avoid that. I have seen people doing this. Sir, a omega n square, a 2 zeta omega n, and then they'll find out omega n and zeta. You can do all this only if the s square coefficient is 1. Most of the students fails to notice this thing. S square coefficient should be 1 before you find omega n and zeta. Otherwise, don't do that. So rewrite this characteristic equation. S square plus 10s plus 144 is equal to 0. So omega n is equal to 12. 2 zeta omega n is 10. Zeta is 5 by 12. Use this value of zeta. Then the damped oscillations frequency comes out to be 10.9. 10.9 is the answer to the question. 10.90, 2 decimals is what you get, radian per second. In this question, consider a lead compensator of the form 1 plus s by alpha upon 1 plus s by alpha beta, where beta is greater than 1 and alpha greater than 0. The frequency at which this compensator produces maximum phase lead is 4 radian per second. At this frequency, the gain amplification provided by the controller, or compensator, you can say, assuming asymptotic Bode magnitude plot of K of S of this compensator transfer function is 6 dB. The values of alpha and beta respectively. To answer to this question, you need to remember the formulas of the compensator. 3 formulas in any compensator. Number 1, what is the frequency where the phase of the compensator is going to be maximum? Number 2, at that frequency, what is the phase produced by the compensator? Number 3, at that frequency, what is the magnitude provided by that compensator? Pay attention. If I say that transfer function of a compensator is s plus z by s plus p, x, which is z by p, x, some notation, ratio of z and p. If this x is less than 1, it is lead compensator, greater than 1, it is lag compensator. And the frequency where the maximum phase is produced by this compensator will be geometric mean of the 0 and pole. Geometric mean of the 2 corner frequencies that are zeros and poles. And the maximum phase that is produced by that compensator, if I say sine angle, it is 1 minus x by 1 plus x. And the magnitude provided by that compensator at that frequency where the phase is maximum is 10 log 1 by x to the base 10 decibel. All these formulas are there in your notes. These are all obtained from the asymptotic Bode magnitude plot. And the analysis of compensator we did using the asymptotic Bode magnitude plot, and these are the results that we have. Remember, if it is a lead compensator, it provides positive phase and amplification. Magnitude will be positive dB, amplification. If it is lag compensator, it provides negative phase and attenuation. Attenuation means negative magnitude in decibels. This magnitude in decibels will become negative. That's called attenuation. This magnitude in decibels will become positive. That's called amplification. So lead compensator characteristics are, it provides positive phase and amplification. Lag compensator characteristics are, it provides negative phase and attenuation. Even this was asked as a question in the previous papers. if you have come across the previous papers, you might be recalling this. Lead compensator provides. Options are positive phase and attenuation, positive phase and amplification, negative phase and attenuation, negative phase and amplification. Answer: positive phase and attenuation. I'm sorry. Positive phase and amplification. See, that's what the word is used by this. The gain provided. See, gain is not a suitable word in frequency domain. Gain is a time domain terminology, magnitude is frequency domain. Some people are casual in using this terminology, it's okay. So, the kind of gain provided by lead compensator will be amplification. The gain greater than 1 is amplification. Gain less than 1 is attenuation. Simple. Let me finish this question. See, the transfer function of this compensator can be written as beta s plus alpha upon s plus alpha beta. So what is the parameter x for us? It is alpha by alpha beta, that is 1 by beta. Remember, beta is given to be greater than 1. So 1 by beta, this will be less than 1. Accordingly, it is lead compensator, and obviously that is mentioned in the question also. Maximum phase lead. What is the frequency at which this is going to be maximum? Under root of the geometric mean of the 0 and pole, alpha into alpha beta, that is alpha root beta, omega m. And this omega m is given to be how much? 4 radian per second. We have to find the values of alpha and beta. And the amplification provided is 6 decibel. This is 6 dB. So 10 log 1 by x. X is 1 by beta. So 1 by x is beta to the base 10 is 6 dB. From this, beta becomes 4. Enough to answer to the question. Option B. That's what I'm saying. See, if you don't focus on the options, unnecessarily you will be solving for alpha also. You're wasting time. You might be thinking, sir, few more seconds. Who knows? It may be few more seconds or ज़्यादा minutes of the time जाएगा किसी और question में. Always be watchful for the options. There is only one option, option B, wherein the beta can become 4. No other option. So I directly say answer is B. I don't even bother about calculating alpha. You can calculate that from this equation. Let's move to the next question. In this question, the following circuit represents what? Lead compensator, lag compensator, lead lag, or lag lead. Look at the board. Let's not waste time in one method is wasting time in finding the transfer function. That's the method that most of the students are going to use. Let us discuss both. That's what I told you. One method, time wasting method, is finding the transfer function and then trying to find out which compensator it is. 90% of the students will be able to do this. Then what is your specialty? 90% of the people will be able to do this. Then what is my specialty? Right. So I don't want to answer this using the transfer function. If you have sound knowledge of operation amplifiers, if you're conceptually good, of course you have. You really don't waste time in solving this. I do like this. Pay attention. It's an inverter. You know? It's just a proportional controller. It's a kind of providing gain. It's just for a gain purpose. Whose transfer function? Minus R3 by R4. That's simple. It's a gain parameter. It has no pole nor zero. This is the one which gives you poles and zeros. This is going to be pole in the transfer function. This is going to be 0 in the transfer function in this inverting mode. This will become a pole, this will become a 0 in the transfer function if you obtain. No need to obtain. T1 is the time constant of the 0 R1 C1. T2 is the time constant of this pole R2C2. It is mentioned that T1 is greater than T2. It means time constant of the 0 is larger. Whichever has large time constant, that will act as a dominant one in the transfer function in the system. Dominant is the one which has got the large time constant, or dominant is the one which is close to origin, either way. So if 0 is dominant, lead compensator, answer is option A. Right? That's what I told you. This is the concept, the beauty of the concept, the depths of the concepts. To a greater extent, we can solve questions quickly. And this is the time, I can try to convince you with all of this. Like in the beginning, when you are learning all these things, if I tell you these things, you will not be able to digest, or you will leave the concept and run behind all these short things. Don't do that. Do it now. When you have prepared the subject thoroughly, completely, when you digested every concept, when you practice the questions enough, now you look for this way of dealing with things. Okay. If you want to actually solve this question, you have to find the transfer function GC. This impedance R2 and C2 in parallel. So R2 into 1 by SC2 upon R2 plus 1 by SC2 upon inverting mode, right? R1 into 1 by SC1 upon R1 plus 1 by SC1 with a minus sign. This impedance I call it to be Z2. This impedance I call it to be Z1. In inverting mode, non-inverting mode, minus Z2 by Z1. Minus Z2 by Z1. This is Z2, this is Z1. Upon simplification, this becomes minus R2 by R1 into SR1C1 plus 1 upon SR2C2 plus 1. Upon simplification, it's going to be this. And we have got another stage cascaded with this. So the final shape of the transfer function is going to be R2 into R4 upon R4 by R3. R1 into R3 minus into minus plus SR1C1 plus 1 upon SR2C2 plus 1. This is DC gain of this compensator. Forget about that. Comparing this one with TS plus 1 upon alpha TS plus 1, the standard time constant form transfer function of compensator. So T becomes R1C1, alpha T becomes R2C2, alpha R2C2 upon R1C1. Okay, so this is like R2C2, T2, and R1C1, T1. What does the question says? T1 is greater than T2. So T2 by T1 will be less than 1. So a transfer function of the form Ts plus 1 by alpha Ts plus 1 with alpha less than 1 will be lead compensator. But why all this unnecessary? We could answer it directly. In this question, consider a system shown in the figure below. The damping ratio for this system without tachometer feedback is 0.216. Without tachometer feedback, zeta of the system is 0.216. However, due to the incorporation of this tachometer feedback in the system, the damping ratio increased to 0.72. Then the tachometer gain kT to achieve this improvement will be. Remember, tachometer is nothing but derivative controller. Again, come to the concepts. what derivative controller does. I told you PD controller acts as a derivative controller in the transient state. Listen, the difference is in case of derivative controller, steady state error increases, but in case of PD controller, steady state error does not increase, rather decreases. That's the difference between D and PD. But when it comes to transient characteristics, they have the same performance. So with and without derivative controller, omega n remains same, but zeta increases by a factor kd omega n by 2. See, due to derivative controller, oh, I'm sorry, spell mistake. Due to derivative controller, omega n same, no change before and after, but zeta will increase. What happens? New zeta will be old zeta plus kt omega n by 2. You say kd or kt or any notation, never bother about the notation. Derivative controller is also called tachometer. If it is tachometer, kt. If it is derivative controller, kd. It's only a matter of notation. Omega n remains same. Okay. What happens to steady state error? I told you in case of PD controller, old steady state error by kp. But in case of derivative controller, steady state error will be old steady state error plus kt. I mean, that's not the point of discussion here. We don't need this. Steady state error new will be steady state error old plus kt. But we don't need this for this question. The question is only about zeta. Old zeta, how much? 0.216. New zeta, 0.72. So I'm saying that if you followed all the concepts and if you followed the analysis and if you have the results with you, there you are. 0.72 is equal to 0.216 plus kt omega n by 2. And we don't know what is this omega n. Actually, omega n is root k. This is omega n square. So omega n of the system is root k. And we don't know what is k. So we have to find that way. This omega n is nothing but root k. So we have to find this, but there are two unknowns involved. So one we will find first. Without tachometer, without kt, this system, what is that? Omega n square is k. See, this is omega n square, this is 2 zeta omega n. 2 zeta omega n is 1. 2 zeta is 0.216. Omega n, that is root k, is equal to 1. You can find the value of k. Otherwise, root k का value ही पता करेंगे because that itself is omega n. Just a second. K value we can find it to be 5.358. 5.358 is the value of k by solving. So from this, using that, this omega n, it is nothing but root k. K is this. So use that. The value of kt gets solved to this one, 0.435. You may ask me, sir, I don't remember this. Then what should I do? Simple. First form the closed loop transfer function. From that obtain the characteristic equation, or I directly form the characteristic equation. From that find out what is omega n and then zeta, and that will be in terms of kt, and use this value of zeta given and solve it and get it from that. But I mean, according to me, if I remember this, then that should be done. And if the question also involves about steady state error, again, you don't have to go to the steady state error formula and calculations. You can get it from here. A closed loop control system with unity feedback is shown. By using a PD controller, 1 plus TDS, the damping ratio is to be made as 0.75, then the value of TD is similar to that of previous question again. See, one thing, transfer function of the controllers, I mean, there are so many formats that are available. There's so much of controversy involved in the transfer functions. Pay attention. PD controller actual transfer function is this. This is the most authentic and proper way of writing the PD controller transfer function, Kp into 1 plus KDS, which can also be written as Kp 1 plus TDS, because Kd is equal to Td, that's okay. And this thing which is mentioned in the question, 1 plus TDS, that is for Kp is equal to 1. It means he has taken Kp to be 1. Yeah, we are allowed to do that. That's not a problem. In the question, the examiner assumed Kp to be 1, and then the form is becoming 1 plus TDS. There is another way of writing the PD controller transfer function, which is not that authentic. It is an approximate way of writing the transfer function of PD controller, Kp plus KDS. I have come across students who constantly asking me through Telegram, through my WhatsApp portal, through my mail messages, wherever, because there are 4 or 5 places where I used to respond to your doubts, queries. Maybe it's a Telegram channel, or some people send doubts on my Telegram and WhatsApp, whatever. There, I see this question constantly. Sir, you told that PD controller transfer function is this, but in the question it is mentioned this, or in the question solution it is taken this. What to do? Here, you have to be careful in this manner. You are not given with a PD controller transfer function. You are not given with a PD controller transfer function. Rather, you are asked to assume that a PD controller is used to improve the system characteristics, then find the value of Kp, Kd. You should be very careful. You should be using this as the transfer function of PD controller. It's not already made part of the question. Terminology says that a PD controller is used with this second order system to achieve these characteristics. Find Kp and Kd values of the controller. You should be using this PD controller, otherwise you're going to be wrong with the answers. Options galat jayenge. Sometimes what the question says, the examiner, he himself gives you the PD controller transfer function or PI controller transfer function. Then he will ask you to find the value of Kp and Kd for the desired characteristics. We have nothing to do with what is given, because options are based on the function he assumed. So we will go ahead with whatever transfer function is given. Even if this is given in the questions, I will take this. Though I know that this is not acceptable, this is a genuine transfer function, but I'm helpless because this is made as part of the question. I will proceed. Right. Like in this question, let me go back to a slide here. We have come across a question just now. See this. In this question that we have solved, PD controller transfer function Kp plus KDS. So I know that this is the wrong function. It should not be taken this way. But I'm helpless because it is made as part of the question and the options will match to this function. So I will take and solve this question. Even there was another question of PI. Just a second, please. See this. This is not a 100% correct transfer function of PI. PI controller transfer function is Kp 1 plus Ki by S. That is Kp 1 plus 1 by TRS. This is the authentic, genuine, 100% correct transfer function of PI. Right. If the question says that, see, this is not given. If this block is not given. Only this diagram is given, and the question says that a PI controller is used along with this plant. Find the maximum value of Ki for the system to be stable or worst case marginally stable. Then I never consider this to be the PI controller. From my side, I will take this thing because it's not mentioned what to take in the question. So then you should be taking this thing. That is the authentic one. And in spite of that, if the option is not matching or if the answer goes wrong, we can challenge that question. You cannot challenge this question now. It says that I have taken an approximate design of the controller. I gave you the function. So according to this function, you work out the answer. So we cannot debate now. When we are mentioned to be PI controller, but the transfer function is not given, and if I should be choosing this, and if the answer is not matching, we can always challenge this question. So you be right with the concepts. Don't worry what people do. Okay, so where I'm here, PD controller is given 1 plus TDS, so I'm ready to accept as it is. The damping ratio has to be 0.75, then what will be the value of TD? So directly using, so I do nothing. Omega n of the system is 2, zeta of the system is 0.5. I want it to be 0.75. So new zeta is equal to old zeta plus KD, that is TD. TD omega n by 2. What is omega n? 2. So answer to the question, TD has to be 0.25. Done. TD 0.25. How does 0.5 becomes 0.75 when you have TD of 0.25? Answer to the question is option A. In the previous question of the same model, I took time to explain, but why do I waste the time again here? So it's a matter of few seconds. Answer is 0.25. The transfer function of a system is 100 upon s plus 1, s plus 100. For unit step input to the system, the approximate settling time for 2% criteria. Believe me, there is a big problem with these damping methods and the formulas that are used. Predominantly, the questions will be of under-damped system, and predominantly we use the under-damped formulas. Rise time, settling time, the formulas that we use, we remember mainly for the under-damped system. At the same time, you also have to know them for critically damped and over-damped system, that what they are. For undamped system, no formulas because it is not stable at all. For under-damped, we have got different set of formulas. For critically damped, we have got different formulas. For over-damped, we have different formulas, both in time domain and frequency domain. That is the important thing. Just a second. Both in time domain and frequency domain, in response analysis, we have different parameters, we have different formulas for underdamped, critical damped and overdamped. Don't try to use the formulas of underdamped for overdamped or formulas of critical damped for overdamped. No, they are all three different things. Overdamped system is similar to that of first order system, approximate. Underdamped system is special. It is not like any other. Critically damped system is special. It's not like any other. Overdamped system is not special. It's like a first order system. Why I'm saying so much? Instead of this MCQ, if it is numerical data type question, I'm sure that a large group of students might have done wrong answer here. See how students used to proceed to this question. See, transfer function means by default closed loop transfer function. Don't go by the notation. I even see people doing like this. कितने सारे mistakes करते हैं देखिए students, confusion की वजह से. They say that sir g of s is given, और आपने कहा था g of s तो plant होता है, और हमको तो settling time closed loop system के लिए पता करनी है. So what we do sir, 100 upon s square plus 101s plus 100 plus 100. They try to form the closed loop transfer function. We know, add the numerator to the denominator. They will take the closed loop transfer function as s square 100 upon s square plus 101s plus 200. They say that sir, this has to be the closed loop transfer function because given is the plant, since notation is g of s. No, my dear, that's wrong. Don't recognize the function by its notation. Recognize the function by its wording. Wording is more important. It is mentioned transfer function. So by default, transfer function matlab closed loop transfer function. So that itself is the closed loop transfer function. You don't have to change it to closed loop further. And what is the formula for 2% tolerance settling time? Again, in hurry, people take this to be, sir, 4 by zeta omega. You only said 4 by zeta omega. And they will find omega n to be 10 and zeta to be 5.05. And settling time 4 by zeta omega n. 2 zeta omega is 101. Zeta omega n is 50.5 something. So they try to do it this way. And from the options, no option matches. If it is not MCQ, if it is a numerical data type question, believe me, people would have simplified this, and 4 by 50, that's like 1 by 25, 0.04. They'll come out with answer as 0.08, sorry. 0.08. Yeah, again. 2 by 25. 0.08. Close to that. So they will write the answer as 0.08 and they leave the question. And there is no way to look back. If it is at least multiple choice question, sir, 0.08 high nahi. So somewhere I went wrong, you can recognize. If it is numerical data question, no way to recognize. So unless you thorough with the concepts, unless you observe the question carefully, it's not possible to get the right answer. This formula is wrong because given is over-damped system and this formula is for under-damped. Over-damped system कैसे पता चला sir? Roots are real and unequal. Roots are real and unequal is the characteristic of an over-damped system. Roots are real and unequal. Direct identification. Otherwise, zeta of the system is greater than 1. That way also you can understand it to be over-damped. What is the settling time of over-damped system for 2% criteria? For T1. What is T1, sir? Time constant of the dominant root. Who is dominant, sir? The one who is close to origin. This is close to origin. This is far away from origin. This is dominant. This is ordinary. So the pole is at -1. Time constant is reciprocal of the distance of the pole from origin. 1 second. 4 into 1. 4 seconds. B is the answer to the question. I see people trying to do like this. They will approximate this transfer function into first order using dominant root concept, then they use the formula. Oh, why do you do that? Don't do that. We approximate this into a smaller transfer function when we are asked to obtain the approximate transfer function. See, if the question says transfer function of a system is 100 upon s plus 1, s plus 100. Obtain approximate transfer function using dominant root concept. Then we do this. We say that 100 upon s plus 1, s by 100 plus 1. We can convert that into time constant form. And we remove this pole. We say that this is approximately equal to 1 by s plus 1. We do this way. So unless we are asked to obtain the approximate transfer function of the given transfer function using dominant root concept, no need to remove that ordinary pole. The question is different, right? If you want to see that, you can see the next question. This question. This is about obtaining the approximate transfer function. Right. So this question, this is about getting that approximate transfer function, okay? Transfer function of a plant is given, a second order approximation using the dominant pole concept or dominant root concept. Now we do that, okay? So remember, in third order system, whether you like or not, second order is always dominant, first order is always ordinary. There is no need to check that who is close to origin, who is away from origin. I mean, one way is people, they try to find the location. People, they try to find the location of the poles. Time waste. They say that one pole is here and the remaining two poles are, one is at -1 by 2 plus j root 3 by 2. The other is at -1 by 2 minus j root 3 by 2. And they say that these two are close to origin, so dominant. And this pole is 10 times away from this pole, so this is ordinary. They eliminate this, then they maintain this. You wasted a lot of time. In third order system, in which you will have a first order and a second order system, second order is always dominant, first order is always ordinary. So this needs to be eliminated, but from time constant form. When you do that, you will get the answer to be option D. Right. So in this question, LTI system is given. LTI causal continuous time system has a rational transfer function with simple poles at -1, -2, and -4, and a simple 0 at -1. Unit step input is applied as the input. At steady state, the output has constant value of 1. Find the impulse response of the system. See, first we need to form the transfer function. First we need to form the transfer function of the system. Transfer function of the system can be formed like this. This has a 0 at -1 and this has poles at -2 and -4. This is the transfer function of the system. See, as far as the poles and zeros are concerned, we got the transfer function. And we are assuming the gain, if I leave it like this, that means we are assuming the gain of the system to be 1. See, transfer function is made up of gain, zeros and poles. 3 things makes transfer function, namely gain, zeros, poles. Zeros and poles we took it to be right. And if I leave it just like this, it means we are assuming the gain to be 1. And how do we know that the gain is 1? So we also have to verify that option whether gain is really 1 or not. How to verify? It is mentioned that input is unit step and the output in the steady state will be 1. From this, you know what we understand, DC gain of the system as output in the steady state upon input given to the system. DC gain of the system is ratio of the output of the system in the steady state to that of the input given to the system. Steady state output 1, input given is 1. DC gain of the system is 1. DC gain means the gain that we obtained by substituting S is equals to 0 in the transfer function of the system. If I substitute S is equal to 0 in this function, then I'm getting it to be 1 upon 4 into 2, 8. According to the statement given, DC gain is 1, but according to the transfer function that we are choosing, the DC gain is 1 by 8, which is wrong. Then, sir, how to make it right? You have to change the gain of the system from 1 to 8. Gain of the system is not 1, it is 8 actually. When the gain is 8, then the DC gain of the system is going to be 1. So now the DC gain of the system is going to be 8 by 8, which is 1. Now right. It means we have a 0 at -1, we have poles at -2 and -4, and we have the gain of the system to be 8, which is not seen in the statement. That's the concept behind this question. Question is speaking about DC gain, but we need to have, the gain of the system in the transfer function. Like, let me take you to this way. Sir, I don't want to go through gain. Then you go through DC gain, and then you need to have the transfer function in time constant form. See, another way of finding the transfer function. This system has a 0 at -1. Write that 0 in time constant form, S by 1 plus 1. It has a pole at -2. So write it as S by 2 plus 1. It has a pole at -4. Write it as S by 4 plus 1. This is time constant form of the transfer function. This is pole 0 form of the transfer function. In pole 0 form, you will have gain. In time constant form, you will have DC gain. The question statement is about the DC gain of the system. So you directly take time constant form. This is the transfer function of the system, which when you convert it into pole 0 form, later it will be the same thing that I have written there. Yeah, what is the question? Question is to find the impulse response of the system. Write it as A by S plus 2 plus B by S plus 4. Find the value of AB, you know how to find. Let's not waste time for the calculations. Answer to the question is option C. Right, pay attention. This is about impulse response. So I have to find the impulse response, no other way. If it is about step response or ramp response or parabolic response or even sinusoidal response, don't waste time in finding the response. What you do, you substitute t is equal to 0 in the given option. Whichever answer becomes 0, that is your answer. Whichever option becomes 0, that is your answer. I need your attention. Accept impulse response. step response, ramp response, parabolic response, and sinusoidal response, they will become 0 at t is equal to 0. Except impulse response, all other responses, they will become 0 at t is equals to 0. Provided if that response is obtained using transfer function and if it is strictly proper. Two conditions apply. You have a response expression. First, you have to see whether it is obtained from the transfer function or from state model. It is obtained from the transfer function. Condition 1 is satisfied. Condition 2, that transfer function, is it strictly proper or improper? It is strictly proper. Second condition is satisfied. Then that response should be 0 at t is equal to 0. If it is obtained from the proper or improper transfer function, or it is not obtained from transfer function at all, it is obtained from the state model, then it need not be 0 at t is equal to 0. And though it is obtained from the transfer function of a strictly proper system, still it will not be 0 if it is impulse response. For impulse response, this concept is not applicable. Reason: impulse response is transient response, and transient response is incomplete response. Complete response obtained using transfer function model is considered to be transient plus steady state. And complete response obtained from state model is considered to be transient plus steady state plus ZIR, zero input response. Okay. So I think answer is over. I'm trying to explain even the story that is behind these questions. It's a very interesting question. You might have come across this in previous papers. And I have chosen this question intentionally to tell you how simple is this and how tough we make it to be. You might have come across this question, I'm sure. The moment I show this question, you'll say that, sir, we know this question. You know this question, but you don't know the simplest and the best way of answering this question. One method you know. What is the question first of all? Consider the feedback system shown in the figure below subjected to unit step input. The system is stable and it has the following parameters: Kp4, Ki10, omega 500, zeta is 0.7. Find the steady state value of the Z. Biggest mistake in this question is Z is not here, Z is here actually. There is a print mistake in this question. The question is reproduced the same everywhere. Z is the output of this adder, output of this PI controller actually. Z is to be there. So you're asked to find what the steady state value of Z. One way to answer to this question is this. As you do. Let me explain the way that you try to answer. First you find Z by R. Z of S by R of S using Mason's formula. Look at the board. Two forward paths. One forward path is this, whose gain is Kp. Another forward path is this, whose gain is Ki by S. Two forward paths. And we have two loops. One loop is of the gain Kp multiplied by the second order system with a -1. One loop is this. Second loop, Ki by S into the second order system with a -1. Two loops. And both the loops are touching to both the forward paths and there is no combination of two not touching. You will be able to use Mason formula and you will be finding Z by R. I'm not doing that. I'm explaining one way of answering to the question, the lengthy way and time wasting method. Z by R. Then what is that we are asked to find? Steady state value of Z. Yani Z of infinity. That is nothing but limit S tends to 0, S into Z of S. Steady state value or final value of Z, Z of infinity, using final value theorem, limit S tends to 0, S into Z of S. This is limit S tends to 0, S multiplied by Z of S. What will be Z of S? This transfer function that you copied here, this thing, you write it here, multiplied by R of S, which is unit step. This and this gets cancelled. Now you will be substituting limit S tends to 0 in this transfer function, you will get the answer. And for that, all the values of the parameters are given, Kp given, Ki given, omega n, this has to be omega n. Omega, no problem. In the question itself, they are taking omega to be, omega n to be omega, there is no problem. And zeta is given, everything is given. By the time you solve this question in this manner, you are going to lose at least 4 or 5 minutes. I give you answer in 5 seconds. You took 5 minutes, I'm giving you the answer in 5 seconds. Sir, how? Look at the board. This is standard second order system. Standard second order system is type 1. Type 1. Steady state error of a type 1 system for unit step input is 0. Steady state error of a type 1 system for unit step input is 0. Forget about even for that. Oh, pay attention. In open loop, it is standard second order. Let me even explain like this, a different way, more simple way. Say this is type 0 system. This much. It is type 0 system because there is no pole at origin. Standard second order closed loop transfer function लेंगे, वहां से open loop लाएंगे, that will be type 1. But this function which itself is in open loop, it is type 0. Type 0 system steady state error for unit step input will be finite, 1 by 1 plus kp. But you are using a PI controller. I told you just before, PI integral, PI and PID, they will make the steady state error 0. So without this, this system has finite steady state error for unit step input. With this, that steady state error is going to be 0. You know what is the meaning of steady state error going to be 0? It means that steady state value of the response and the input value will be same. Steady state error is the difference between input value and steady state value of the response. Steady state error 0. It means steady state value of the response is same as the input value. Your input is 1. Steady state value of the response is 1. Okay, no? So even if you do all this, your answer is going to be 1. Unit step response of a unity feedback system with open loop transfer function k upon s plus 1 s plus 2 is shown in the figure. The value of k is given is open loop transfer function, that is to be taken care. So open loop transfer function of a system is given, but remember the response is always for closed loop system. So this is the step response of a closed loop system. Whose open loop transfer function is this? Question is to find the steady state, the value of k. Look at the board. Sir, from the response, we see that the steady state output is 0.75 and input is 1. As you told that this has to be the DC gain. Correct. This is the DC gain, but this is closed loop DC gain. We always talk about the response for a closed loop system. So if I say that steady state output upon input is the DC gain, then that is closed loop DC gain. That is not open loop DC gain. It's a mistake that people do. So 0.75 is the DC gain, closed loop DC gain. So open loop transfer function is k upon s plus 1, s plus 2. This is open loop transfer function. But if I want to find the closed loop transfer function, then add the numerator with the denominator in case of unity negative feedback consideration. So this is the closed loop transfer function of the system. Now what is its DC gain? If you substitute s is equals to 0, it is k upon k plus 2. K upon k plus 2. So k by k plus 2 is 0.75. 0.75 का मतलब है 3 by 4. Yes. 3k plus 6 is equal to 4k. K is equal to 6. Done. Answer to the question is 6. This is one method to answer to the question. There is another way of answering this question. Let me explain all possible ways. The other method is, this system has steady state error. This system has steady state error, which is nothing but input minus final value of the response. I told you just now. In the previous question, I was talking about this. Steady state error is the difference between the input value and final value of the response. So 1 minus 0.75, 0.25 is the steady state error. Input is unit step and given system is type 0. This system is type 0. Steady state error of a type 0 system for unit step input is 1 by 1 plus Kp. This is given to be 0.25. From this, we can obtain Kp to be 3. What is Kp, sir? This is DC gain. DC gain. But this is open loop DC gain. Pay attention. We have DC gain for the closed loop as well as for the open loop. Open loop DC gains are referred by Kp, Kv, Ka. Closed loop DC gain is not referred by any notation. Kp is the open loop DC gain of a type 0 system. Kv is a type for type 1. Ka is for type 2. So we can find DC gain for both open loop and closed loop. It exists for both, but you have to use them very carefully. This Kp is DC gain, but that is open loop DC gain. K upon S plus 1, S plus 2. Substitute S is equals to 0 in this one. This is K by 2. ये भी DC gain है. Difference देखिए. K by K plus 2. This is closed loop DC gain. K by 2. This is open loop DC gain of the same system. Okay. Now, Kp, which is open loop DC gain, K by 2, that is equal to 3. So, K by 2 is 3. So, K is equal to 6. Another way. So, I solved this question both using open loop DC gain as well as closed loop DC gain, just to make the things clear, that have no confusion between them. They are two different things. Consider the block diagram of a system shown in the figure below. If the sensitivity of the overall system with respect to the gain K is 0.3 under steady state condition, then the value of K is steady state sensitivity of the system with respect to the parameter K is mentioned, and then we have to find the value of K. We need to go through calculation for such questions. No simple methods, nothing. Sensitivity of the transfer function with respect to K is K by T multiplied by delta T by delta K. In this, you have to put S is equals to 0 after doing the calculation. That is what mentioned to be 0.3. From that, we get the value of K. After the calculations, after doing all this calculation, this becomes 5 upon 5K plus 5. This is 0.3. From this, we can solve the value of K to be 2.33. 2.33. See, sometimes sensitivity comes out to be a negative value, sometimes it comes out to be a positive value, and you are going to write it to be the same thing that you get it to be. Don't apply modulus and make it positive. Here, of course, you're getting it to be positive. In some questions, sensitivity becomes negative. Some students, they apply modulus, they take the magnitude of that and they write only the positive value, they don't want to take negative. You should be writing it to be negative if it is becoming negative after calculation. So in numerical data type, you have to be more careful. If it is MCQ, okay, you will be given the options ek hai plus, dusra minus. If you are getting minus, you choose minus. But numerical data type, if you're getting it to be minus, write it to be the minus thing. In this question, block diagram representation of a controller P plus D controller is given. P plus D. Many ways to use PD controller. See, in the questions that you saw earlier, P plus D, that was in series. PD, that was in series directly. But here, P is in series, D is in feedback. Even this is a way of implementing a PD controller. So design of a system is never a unique way of doing it. So I want to implement a PD controller in a control system. You have more than one possible way. You can have P plus D in series with the plant, P plus D together. Or you can have P in series and D in feedback. Even this is also considered as PD controller. So you are using D controller in feedback with the plant. To that combination, you are using P controller in series. The question is simple. The value of alpha such that the settling time of the system for 2% tolerance is 0.8. For settling time for 2% tolerance is 4 by zeta omega n for an underdamped system. But this zeta and omega n should be the new zeta, new omega n using this P plus D controller. So what I told you, new omega n will be root kp times of the old omega n. New omega n will be omega n. New will be root kp times of omega n old. Zeta new, I gave you the formula. Zeta old plus kd omega n by 2. Kd is this. This k is kp. This k is kd. You have the formulas, right? So what is old zeta, old omega n? You find from that. Old omega n is 1 and old zeta is S 2 zeta omega n is 1. 2 zeta omega n is 1 and omega n is 2. So 0.25. So find old zeta, old omega n from the plant. Find new zeta and new omega n from the PD controller's analysis, which is this. Then settling time, it is 4 by zeta omega n. How much this has to be? 0.8 seconds. Then you can find the value of alpha from that. According to my calculation, 2.25. We have got an open loop transfer function, 1 upon s square plus 3s plus 2, and we have got an integral controller in series. What does the question says? The positive values of k for which there are exactly 2 poles of the unity feedback system on the j omega axis is equal to. For what value of k? Exactly 2 poles will lie on the j omega axis. See, for 2 poles to lie on, of course, this is going to be a third order system with the help of this controller. And 3 poles cannot lie on the j omega axis because poles that lie on the j omega axis are always in pair. So 2 only can lie out of 3. And if 2 poles are on the j omega axis, this system is going to act as an undamped system. Roots are imaginary, undamped. Undamped system means marginally stable. Question is to find the condition of marginal stability. As simple as that. What is the characteristic equation of the system? S cube plus 3s square plus 2s plus k is equal to 0. This is multiplied by k by s, right? Controller. S cube plus 3s square plus 2s plus k is equal to 0. In a third order system, the marginal condition of marginal stability is product of this inner coefficient should be equal to product of outer coefficients. So k marginal is going to be 3 into 2, 6. Answer to the question is 6. That way. We have a polynomial where k is an unknown real parameter, the complete range of values of k that has got all its roots on the j omega axis. That's a good question and it makes you to think in a different angle. It's a fourth order system. All four roots of this polynomial, they have to be on the j omega axis. See, when all the roots will lie on the j omega axis, according to Routh array, when like fourth order system, right? All four roots to be on the j omega axis, S cube row has to be 0 and no sign changes should happen among the first column elements. Try to understand. For the roots to be on the j omega axis, a row of Routh array has to be 0 completely. Not enough. There should not be sign changes as well. Otherwise, whenever a row becomes 0 completely, it is not compulsory for the roots to be on the j omega axis. They can be anywhere in S plane, but they should be symmetric to origin. So, whenever a row becomes 0 in Routh array, it means that roots are symmetric to origin, not essentially on the j omega axis. But if you want them to be particularly on the j omega axis, then apart from row becoming 0, there should not be sign changes among the first column elements. Then you can authenticate that they are on the j omega axis. Am I clear? So, for the roots to be symmetric to origin, it is enough that a row has to be 0 completely. But those roots that are symmetric to origin, they have to be on the j omega axis. Then, apart from row becoming 0, there should not be any sign change among the first column element. Then this can happen. And that's what has to happen now. S to the power 4, 3, 2, 1, 0. 1, 0, 5, 0, 4, 3, 2, 1, 0, k plus 4. S cube row 0, which means that four roots are symmetric to origin. Now, for them to be on the j omega axis, I should not get any sign change in this part. Let us complete the Routh array first. Differentiating this auxiliary polynomial, 4s cube plus 10s. Right. So 4 and 10. This is 4, this is 10. 20 minus 10. Right. This element is going to be 20 minus 10, 10, 10 by 4. 10 by 4, 5 by 2, 2.5. And this will be k plus 4. This element, it is 25 minus 4 into k plus 4 upon 2.5, k plus 4. So as I said, there should not be any sign changes as well. So k greater than minus 4 is one thing, and 25 greater than 4k plus 16. So k has to be less than 9 by 4. Answer to the question is option A. That's simple. This question, of course, I mean, it came just in my way. The given is a transfer function, which means it is closed loop transfer function. How many poles are in the right side of S plane? Number of sign changes among the first column elements indicates number of roots in the right side of S plane. So there's nothing that you have to do. Simply pick this denominator polynomial, form the Routh array, see the sign changes. Those many will be in the right side. I mean, 2 roots are in the right side. The minimum value of alpha for the system to be stable. Find the characteristic equation, form the Routh array. Another simple question. I mean, already I think we've taken enough time. Right, so same thing, form the characteristic equation, form the Routh array. I just wanted to say this thing. You will get answer to be alpha greater than 0.618. Finally, the value of alpha you're going to get as the stability condition in this question to be stability condition, alpha greater than 0.618. I've seen people taking alpha to be 0.618. That is the minimum value of alpha. No, that's not the minimum value of alpha. Minimum value of alpha should not be the boundary condition, because for boundary condition, again the system becomes marginally stable. So this is going to be the stability condition. The minimum value of alpha for the system to be stable, let's say 0.62. 0.618 से greater होना चाहिए, 0.619, let's say 0.62. This is the transfer function of the forward path, value of k for which sum of its poles lies on the geometric axis. Similar to that of equation that we have solved. Third order system, sum of the poles have to lie on the geometric axis, which means that only two poles can lie in a third order system, irrespective of the number of zeros. Number of poles is order. In a third order system, at the maximum, two poles can lie on the geometric axis. Marginally stable system. So you can find it to be like the product of inner coefficients is equal to outer coefficient and find the value of k. Open loop transfer function of a system is given, the value of k for which this point lies on the root locus. See, when it is mentioned that this point lies on the root locus, now it's not our responsibility to verify whether it really lies on the root locus or not. I've seen some people, I'm taking this question particularly because some students keep asking me, sir, do I need to verify that this point is lying on the root locus or not using phase condition? And then I use the magnitude condition to find the value of k. It is mentioned that this point is lying on the root locus and you find the value of k. So it's not our responsibility to check the presence of the point on the root locus. Though it is not lying on the root locus, we believe that it is lying on the root locus because it is mentioned in the question, and we proceed further. So let's not enter into unnecessary calculation that checking whether it is lying on the root locus or not, and then we go ahead. Waste of time. We are not asked to find whether it is on the root locus or not. We have to find the value of k. You might have seen a condition called magnitude condition. There is another way to find the value of k. I just wanted to discuss that. See this place. This system has a 0 at minus 4, 0, a pole at minus 8, 0, and two poles at s square minus 1, s plus 3, s minus 3. One pole is at minus 3, other pole is at plus 3. S plus 3 and s minus 3. Right. These are the poles. Ye 0 hai. This is pole, this is pole, this is pole. And what is the point? Minus 1, 2. Find the distance between them. 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 Under root of, how much is that? Minus 4 plus 9 plus 4. What about the distance between these two? Minus 8 plus 1. Under root of 49 plus 4. This distance. Under root of minus 3 plus 1 to 4 plus 4. This distance. Under root of 16 plus 4. 3 minus of minus 1, 3 plus 1, 4 square, 16, 0. What is the value of k? Product of length of the phasors drawn from all the poles to that point upon product of length of the phasors drawn from all the open loop zeros to that point. This is one way of finding the value of k. Distance between 2 points. Another way is that magnitude condition. You can say that magnitude of this function at this point minus 1 plus j2 should be 1 because it is mentioned to be lying on the root locus. From this also you can find the value of k. You will get it to be 25.5. See how much this becomes. Let me check the calculation once. 8480 92 divided by 3.6. Same thing. This also becomes 25.5. One more question of this kind. We have to find the value of k at the point minus 2.75 that lies on the root locus. See, this system has a 0 at minus 3 comma 0, a pole at minus 2 comma 0. This is 0, this is pole, and the point is minus 2.75 comma 0. Find the distance between these two, 0.25. Find the distance between these two, 0.75. The value of k is product of length of the phasors from those open loop poles upon open loop zeros. This has to be 3, but there is a danger here. This method, this formula, it's actually a property of root locus. What does it say? The value of open loop gain at a point on the root locus is given by product of length of the phasors drawn from all the open loop poles to that point upon product of length of the phasors drawn from all the open loop zeros to that point. Fine. I'm using this, but you have to be careful here. The property is talking about open loop gain. Property is not talking about k. Open loop gain of this system is 10k. It is not k. There are so many cares that you need to take. Sir, this is non-unity feedback. How to obtain the open loop transfer function of the system? Oh, come on. It is product of the forward path transfer function and feedback path transfer function. Pay attention, please. We obtain the open loop transfer function by converting the non-unity feedback system into unity feedback system only for the calculation of steady state error and nowhere else. Since we know something and we try to use it everywhere, we learn things, but we don't know its applicability. I told you to convert non-unity feedback to unity feedback before you obtain the open loop transfer function. But that is applicable only for steady state error calculation, not for other purposes. This is non-unity feedback, and I want to obtain its open loop transfer function. If it is about steady state error, if anyone asks me, this is the block diagram of a system. Find the value of k such that the steady state error of this system for step input is 0.5. If I get a question like this, then I'm never going to use this open loop transfer function. I have to convert this non-unity feedback into unity feedback. We have a formula, g by 1 plus g into h minus 1 is to convert non-unity feedback to unity feedback to obtain the open loop transfer function. Then we use that open loop transfer function and we obtain the value of k from that. But if it is not about steady state error, I repeat, if it is not about steady state error, you will never convert non-unity feedback to unity feedback. If it is non-unity, keep it to be non-unity. If it is unity, keep it to be unity. You do nothing. Another issue here. Sometimes the question will be asked to find the type of a system. You will be given with a block diagram representation of a non-unity feedback system. The question is to find the type of the system. Question is to find the type. Don't change the feedback from non-unity to unity. Sir, steady state error is calculated using type. Oh, come on. Type is not only used for steady state error, type is used for 100 places. Type is used in the root locus concept. Type is used in polar plot. Type is used in the Nyquist plot. Type is used in the Bode plot. Type is used at several places. If the type is associated only for steady state error calculation, that's a different matter. That's what I'm telling you. See, steady state error is calculated using the type of the system. To find type of a system, you don't have to convert feedback from non-unity to unity. to find the steady state error using that type, then you first have to convert non-unity to unity, then find the type and then find steady state error. Am I clear? Suppose if this question, sir, iska type kya hoga? Type 0, man. This is type 0. I will multiply G with H. I will obtain open loop transfer function directly, G into H, and I will comment on the type of the system. Suppose if you tell me, sir, what is the, let us say K is equal to 5, and say, sir, find what is the steady state error of the system. You know what I do? I will convert this non-unity feedback into unity feedback first. Then I will obtain a new open loop transfer function, and that may be type 1. Maybe type 1. I don't know. वो करने के बाद ही पता चलेगा. And accordingly, I will go for the steady state error. So what you need to understand, open loop transfer function is never unique. One system can have more than one open loop transfer function depending on the requirement and applicability. It is a closed loop transfer function which is unique. And only to find the steady state error, you will be converting non-unity feedback to unity feedback. You never bring this concept in any other place. Even if anyone asks you to find the type of a system which is used to find the steady state error, even to find that type, you should never convert non-unity feedback to unity feedback. Because type is used not only in the steady state error calculation, it is used in other places. Number of semicircles of infinite radius in the Nyquist plot indicates the type of the system. Initial phase of the polar plot indicates the type. Initial slope of the board plot indicates the type. तो वहां थोड़ी हम convert करते बैठेंगे, नहीं करेंगे. Only for steady state error. Okay, so I just got carried away with the discussion. This is the open loop transfer function of the system. Open loop gain is 10K. Open loop gain is not K. So this property will provide open loop gain which is nothing but 10K, not K. So K का value जो है ना वो 0.3 है, not 3. So if you're using this property, you have to be careful what is open loop gain. If it is magnitude condition, don't bother. Magnitude of this open loop transfer function at S is equal to minus 2.75 is equal to 1. From this, you will get the value of K to be 0.3 again. Fine. Root locus of a system is given. Question is to find the open loop transfer function. Observe the root locus, that should be enough. See, from the same point, all the root locus branches are originating, and how many of them are there? 1, 2, 3, 4, 5. We have 5 branches in the root locus, so the system should have 5 poles, and all the 5 poles should be at the same location. And all those 5 poles are real because they are originating from the real point. And no zero in the transfer function because all the 5 branches are arriving at infinity. So keeping all this in mind, the answer is option A. That's it. Yeah. This has 5 poles, but they are imaginary. But we are looking for 5 real poles. These are 6 poles. So out of discussion, directly option A. This question is about the breakaway point of the system. First thing, you need to find the solutions of dk by ds. Then you have to check which solution lies on the root locus. And then you have to check if more than one solution of the dk by ds is lying on the root locus. Breakaway point is that where k is going to be maximum, and break-in point is that where k is going to be minimum. To this extent, you have to take care. I repeat, either to find breakaway point or break-in point, first you have to obtain the solution of dk by ds. Then you have to see that which of those solutions of dk by ds is lying on the root locus. And if more than one solution of the dk by ds is lying on the root locus, then you have to see at which solution of dk by ds is k is maximum and which k is minimum. You have to find the value of k also, if more than one solution is found to be lying on the root locus. Then you say, wherever k is maximum, that is breakaway. Wherever k is minimum, that is break-in. In this question, you will get 2 solutions of dk by ds. These are the 2 solutions of dk by ds. But only this will lie on the root locus, not this one. So now there is no problem. Whether you call it to be breakaway or break-in, doesn't matter. It is only one solution. There is no confusion. Sometimes what happens, you will get 2 solutions of dk by ds, and both of them are lying on the root locus. And the question particularly talking about breakaway point. So it may happen that one is breakaway point, the other is break-in point. So you may confuse between them. Instead of answering the breakaway point, you might be giving the break-in value. So then you have to find the value of k at those points, and wherever k is maximum, that is breakaway, wherever k is minimum, that is break-in. Another way, the point that gets formed between two poles is breakaway, and the point that gets formed between two zeros will be break-in. Right. So this question is about, previous question was about finding the breakaway point, and this question is about finding the value of k at the breakaway point. So you can find the solution of dk by ds and get the solution, see which is lying on the root locus. Then at that you can find the value of k using either of the two methods that I taught you earlier, by finding either length of the phasor or by going the magnitude condition. Or you can also substitute in the characteristic equation and you can find the value of k. There are many ways to do that. In this question, it says that the root locus will be circle. Find the equation of the circle. Let me generalize this forever so that you can answer to all such questions. Pay attention. Whenever the open loop transfer function is of the form k s plus a upon s plus b s plus c, then root locus will be circle provided a greater than b and a greater than c. Complementary root locus will be circle, वो भी circle बनेगा, provided a less than b and a less than c. And the center of the circle will be, in either case, minus a comma 0. Radius of the circle will be a minus b into a minus c under root. So now you can pick the answer. Minus 3 comma 0 will be center. And radius will be root of 3 minus 0 into 3 minus 2 root 3. So circle equation x plus a square plus y plus b square is equal to r square. So answer to the question is option C. Right. So you can answer to the question this way. Question is to find the point at which the root locus intersects j omega axis. That's what, what is the order of the system? 1, 2, 3, third order system. You can form the characteristic equation. You can say that product of inner coefficients and outer coefficients. Achha, the question is to find the point. We can do like this. Form the Rautare. Form the Rautare. By equating s power 1 rho to 0, we will find the value of k. I can do one thing. Without Rautare also we can manage. What is the open loop transfer function of the system? Minus 1 plus r minus j1, right? K upon s plus 4 s square plus 2s plus 2. Characteristic equation of the system is s cube plus 2s square plus 2s plus 4s square plus 8s plus 8 plus k is equal to 0. That is s cube plus 6s square plus 10s plus k plus 8 is equal to 0. Okay, so 6 into 10 is equal to k plus 8, 60, k is equal to 52. For this value of k, root locus will intersect j omega axis. See, the easy way, the point of intersection you can obtain by even coefficients. You can say that 6s square plus k plus 8 is equal to 0. 6s square plus 60 is equal to 0. S is equals to plus r minus j root 10. This is the thing. Almost done. This question is about finding the transfer function from the board plot. See, most of the times what students do, they try to obtain the transfer function and then verify from the options. and you will find another trouble again from the options. If you obtain, that may come out actually from board plot we get the time constant form of the transfer function, but options will be given in the pole zero form to confuse you further. So first you have to obtain the transfer function in time constant form and then convert to pole zero form, then match with options. Better you try to verify from the pole zero location. If that helps you, you can quickly finish the question. See, this system has no pole or no zero at origin because initial slope is zero. All of them are satisfying this condition. Slope is becoming positive, so corner frequency 1 will be a 0. This will be 0. So answer cannot be this, cannot be this. Then at corner frequency 10, slope is decreasing, so this should be a pole. 10 should be a pole. Okay, pole 0 तो सेम आ गया ना, ये दो तो एलिमिनेट हो गए. 1 is 0, 10 is a pole, 100 is a pole, 10 is a pole, 100 is a pole. These two are satisfying the pole zeros. Sometimes, if we are fortunate enough, we can get one answer. Now 2. Now we just have to find the value of k again. At frequency 1, the magnitude of the first factor is 20 log k to the base 10. So k becomes 0.1, but that is in time constant form. In pole zero form, so 0.1, s by 1 plus 1, s by 10 plus 1, s by 100 plus 1. So 0.1 into 10, 100, 10 square. Answer is C, not B. See, polar plot of the system is given for k is equal to 1. The question is to find the values of k for the system to be stable. So in this, I just wanted to add one thing like this. It is mentioned that this is for k is equal to 1. Sometimes it will be given that for k is equal to 2 or for k is equal to 10, something like that. In such cases, how to manage? This is given to be for k is equal to 1, but sometimes they say that it is for k is equal to 2. Sometimes they say that this plot is given for k is equal to 5, and then you try to answer to the question. Listen please. You have to multiply all these intercepts with k. It is actually given to be minus 8, but you have to make it as minus 8k. Minus 8k becomes minus 8 when k is equal to 1. Suppose if the question says that for k is equal to 2, then what is that you need to do? Whatever intercepts are given, suppose if minus 8 is given, you divide that with the value of k. If it is given to be 2, then you multiply with k. So minus 8 should be written as minus 4k if the question says that the plot is given for k is equal to 2. Because now if I substitute k is equal to 2, minus 4k will automatically restore to minus 8. So I repeat, like I say like this, whatever intercept is given, you divide with the value of k and then you multiply with k. Right. What does the question says? Find the condition of stability. Listen please. For k is equal to 1, minus 1 is here, which is coming to the left of the polar plot. This system is stable. So for given value of k, system is stable, which is k is equal to 1. Answer cannot be this. Answer can't even be this. Oh, no, I'm sorry. Can't be this. Because such a value of k never exists. Such a value of k doesn't exist. And this option does not include this value of k for which your system is stable. If you work on the options, mostly you will be close to the answer. So k less than 1 by 8 and k less than 5, or k less than 1 by 8 and 1 by 2 less than k less than 5. Either of them has to be the answer. System is stable when minus 1 lies to the left of the polar plot. This is minus 0.2k, this is minus 2k. So this location will verify this, and this location, which is between these two values, will verify this. Without solving, you can get the answer option B. Okay. Board plot of a minimum phase system is given. How many poles and zeros the system has? Initial slope minus 40, 2 poles at origin. Then slope becoming minus 20, so 1, 0. And slope is becoming 0, again 1, 0. So this system has 2 poles and 2 zeros. Nyquist plot of a system is given. Question is, for k greater than 5 or 4, how many number of poles of the characteristic equation will be the total number of poles in the right side of the equation. Nyquist plot of a stable system. This is the important information. See, sometimes this information will be missing. If you come across previous papers, you might have seen some questions where they confuse that they have not mentioned anything about P. P stands for number of open loopholes in the right side of S plane. I've seen people asking me, sir, इसमें तो P कैसे निकाल लिया उसने? Sometimes this thing will be missing. See, we have to be given with the open loop transfer function to find how many open loopholes are in the right side. If that is not given, at least it should be mentioned in the question that what about how many number of open loopholes on the right side. Neither they give the open loop transfer function nor they mention about this in the statement. Then we assume P to be 0 by default. We assume P to be 0 if nothing is mentioned in the question. Stable system. Nyquist plot is obtained for an open loop system. Open loop system is stable. It means no open loop hole is in the right side of S plane. P is equal to 0. Question is, how many number of closed loop holes lies in the right side for this value of k? See, k greater than 5 by 4 means 4k by 5 greater than 1 minus 4k by 5 less than minus 1. This is minus 4k by 5. If that is less than 1 means minus 1 is inside the Nyquist plot. So minus 1 is encircled 2 times in the clockwise direction. By default, we assume the Nyquist contour to be in the clockwise direction. So for clockwise direction of the Nyquist contour, encirclements of the Nyquist plot in clockwise direction are taken to be negative, and encirclements in the anti-clockwise direction will be positive. There are so many defaults that you have to assume. Suppose if the Nyquist contour is taken in anti-clockwise direction and the Nyquist plot is obtained, then the encirclements of the Nyquist plot with respect to minus 1 in the clockwise direction will be positive, anti-clockwise direction negative. In this case, n is minus 2. Number of closed loop holes in the right side of S plane P minus n, 2. Hardly 5-6 questions. We are almost done. I tried to pick question from almost all the topics. So I'm left with 5-6 questions. Open loop transfer function of a system is given. Its root locus technique will give stable system for k greater than minus 4. Gain margin is equals to 1. Phase margin is equal to 180 degree. Which of the following statements are true? If you solve it, going to be lengthy. Let me make the thing simple. It's a second order system. Second order system is absolutely stable. Pay attention. First and second order systems are absolutely stable. This system is stable for any value of k greater than 0. First and second order systems are absolutely stable with a negative feedback. Look at the board. This is the root locus of the system. This is the complementary root locus of the system. Complementary root locus is obtained for negative values of k. Distance 2 into 2, 4. It means with the positive feedback, this system is stable for k greater than minus 4. With a negative feedback, this system is stable for k greater than 0. Question says stable for k greater than minus 4. So when it is greater than 0, why we are taking it to be greater than minus 4? That's about CRLD. Yeah, that's true. In CRLD, it is stable for k greater than minus 0 to minus 4. Stable system. Give me a second. Give me a second. 0 degree, 180 degree, P minus Z2. Not stable. K less than minus 4, man. It has to be. Here K is minus 4. So for the values of K from 0 to minus 4, the system is stable. Work out for the characteristic equation. Let this gain be K. S square plus 4S plus 4 plus K. K greater than minus 4. That's right. K greater than minus 4 means minus stable for 0 to minus 4. My mistake. K has to be greater than minus 4. Correct. The complete condition of stability is minus 4 to infinity. It means it is stable with the positive feedback for the values of K from minus 4 to 0, and it is stable with a negative feedback for the values of K from 0 to minus 4. That's right. So K is 0 here. K is minus 4 here. So when K is varied from 0 to minus 4, your system is stable. Correct. Listen, gain margin 1 means 0 dB. Stable systems gain margin cannot be 0 dB. That is marginally stable systems. This is true, then this is false. What about phase margin, sir? Who wants to solve? It's about the two statements, right? All cannot be true. Second is not at all true. So answer is 1 and 3. Okay, na? Options ka istemal kar. Don't verify the third statement. Based on the options, answer has to be option B. Don't solve whether really phase margin is 180 or not. Because to find phase margin, you have to go for gain crossover frequency, then phase at gain crossover frequency, then 180 plus that phase is phase margin. Lengthy. Another interesting question. This is the open loop transfer function. Question is to find the gain margin and phase margin at omega is equal to root 2. See this please. You have to find gain margin as well as phase margin of this system at frequency root 2. Remember, gain margin is found at phase crossover frequency and phase margin is found at gain crossover frequency. And you are asked to find gain margin and phase margin at this frequency means this omega root 2, this itself is omega GC, this itself is omega PC. And when omega GC is equals to omega PC, system is marginally stable. Answer to the question is 0, 0. If you solve, you will waste time. Be conceptual, matter solved. Yeah, see this question, lot of students ask me about this. Let's see how to choose the options given. I'm almost done, just 5 minutes. This question is from the previous papers, but the mistake that is done in the papers is, previous papers, state variable location is not given. If you have come across this question from the previous papers, you will realize that state variable location is not given. I have taken the location. These are the options. And if I change the options, if I change the location, see, for this location of x1, for this location of x2, output of integrator x1, second one, for this location of x2, for this location of x3, one of the options matches. Right, pay attention. Suppose if I change the location, then none of the options will match. Because the position of the coefficients matters, right? So with a great difficulty, I could trace out with all the permutations combinations that for this location, the answer is going to be from the options. It's a very unfortunate thing. If this question comes in the exam without marking of the state variables, more than one option cannot be possible. If it is MCQ, only one answer will be there. Which one? That we can find out when the fixed location of the state variables are given. So if the state variable locations are not given, then it's going to be a very big challenge for us, because with this location, the position of the coefficients will be in one of the options. If I reshuffle the variables, and there is no sequence to assign the state variables, you may argue, sir, why this should be x2? I call this to be x2, that to be x1. Yeah, you're right. But no option will match from that. So it becomes the responsibility of the examiner in such questions that they should be declaring the position of the state variables to suit the given option. If that is missing, we have to challenge this. So as far as this location is concerned, I mean, we have to find the equation, state equations, like output of integrative is state variable, then input will be its derivative based on the location. With this position, answer is going to be option D. How do we write the equation? Sum of all incoming branches, x1 dot is equal to this plus this. Similarly, x2 dot is equal to this plus this. x3 dot is equal to this plus this. Okay. So the only difficulty involved in this question is it's easy, not difficult. But this question, when it appeared in the exam, state variable locations are not given. So randomly people try to assume one student will take this x1, this as x2, this as x3. With that, if you write the equation, no option will match. Some other student will take this as x2, this as x1, this as x3, and they write the equation. No option given will match. So you get frustrated. And we cannot make this many combinations, right? So how do I read the mind of the examiner that he has taken this as x2, this as x3, and this as x2 and x3? It has to be mentioned. Otherwise, we have to challenge that. So it's not our fault. It's the fault of the examiner himself. Yeah. So again, state diagram is given. Obtain the state model. The method is consider the output of integrator to be state variable and the input to be the derivative of the state variable. Write the equations as sum of all incoming branches, as I showed in the previous one. And then check that. Waste of time. Some state diagrams will be of peculiar form. Some state diagrams will be of peculiar form. Pay attention. If the loop starting from different nodes and ending at the same node, it will be controllable form. If the loops are starting from the same node but ending at the different nodes, that will be observable form of the state model. This state model is going to lead to observable form. What is observable form? Coefficients of the characteristic equation will be found in the column of A matrix. These are the coefficients of the characteristic equation. They will be found in the column of A matrix. Answer cannot be this, answer cannot be this, answer can be either this or this. चार में से दो ऑप्शन गए. -1, -1, -1, -1. You will find them in a column. If it is controllable form, you will find -1, -1 in a row. Sir, अभी भी तो दो ऑप्शन बचे हैं ना? Right. Say this. दोनों का B same है. Matter is about C. Matter is about C. Pay attention, please. Let us say that output of this integrator is x1, output of this integrator is x2. Y is equal to 0.5 x1 minus 0.5 x1 plus 0.5 x2. एक इक्वेशन लिखना होगा आपको बस. So answer is option B, not D. 0.5 x1 minus 0.5 x1 दो है ना, and 0.5 x2. So answer is option B, not D. That's simple. In this question, transfer function is given, state model is given, A, B matrices are given. What about C? One method is direct method of decomposing. Rationalize with the highest power of S, arrange in the form of Mason formula, obtain the state diagram, write the equations, get the state model. From that you verify. At least 5 minutes. We need only 5 seconds. Look at the board. Coefficients of the characteristic equation from right to left with opposite sign will be appearing either in a row of A matrix or column. If it is row, controllable form. If it is column, observable form. Minus 6, minus 5. Minus 6, minus 5. They are in a row. A matrix verified. We don't have to verify that, but verified. B में क्या होगा पता है? Gain of the system. Gain is 1. C matrix will consist of coefficients of the numerator polynomial from right to left without sign changes. Coefficients of the numerator polynomial from right to left without sign changes. So C will become 6 and 1. Direct. D matrix will be 0 as long as it is strictly proper transfer function. Matrix D will be 0 as long as it is strictly proper transfer function. This question you can solve later. The question is, I just want to explain the idea behind that. It's a state model. Question is number of closed loopholes that lies on the right side of S-plane. For such questions, we have no option other than going through RH criteria. See, even if it is state model, if the question is about the condition of stability, if they say that find the stability condition or find how many roots are in the right side of S-plane, any such question that has to be dealt through RH criteria, it is very much applicable. So what you have to do, you have to form the transfer function. And to form the transfer function also we have easy methods, but not applicable for such a arbitrary form of the state model. Remember, only 4 forms are standard: controllable form, observable form, diagonal form, triangular form. For them, we can have the short methods, but if it is in random form, there is nothing that we can do. We have to go through the entire procedure. No need to form the transfer function. We need to form the characteristic equation because the question is about finding number of roots in the right side of S-plane. Mod Si minus A is equal to 0 is the formula to find the characteristic equation from state model. This is A matrix. Form the characteristic equation. Then form the route array. And then you will find the number of sign changes from the route array that will indicate the number of roots in the right side of S-plane. You're going to get 1 sign change. I'll give you this plus 6, which question it is. Zero, 3, 1. Characteristic equation of this system is going to be S cube minus 2s square minus 7s minus 13 is equal to 0. Form the route array, you're going to have 1 sign change. So that means 1 pole is on the right side of S-plane. This way. So these are some of the selected questions from all the topics, and I tried to recall all the concepts with an alternate ways to solve the questions. Hope this would have definitely helped you to improve your understanding about this subject. So one last piece of advice: be watchful for the speed and for the accuracy. For control system also, speed and accuracy are important, and they are very important for you in the exam. You need to maintain speed in solving questions. At the same time, you have to be highly accurate. Be careful, and this comes not all of a sudden. It comes with a great practice. You still have time. Practice more number of questions, and at this point of time, don't learn anything newly. This is not the time to learn. This is the time to practice and to master what you have already learned. So the mistake that people do is, if you have not learned a particular topic of, let me take control system. If you have not learned a topic so far, don't learn it at this time. There is nothing that you can do now. You hardly have got 2 weeks of the time for the exam. If you have not learned a topic so far, don't do the mistake of learning it now. That is going to damage the topics that you have already learned. So leave it now. Whatever you have learned, you excel in that. That is the time. And you practice more those things that you have already learned, and maintain speed in the exam. Don't do mistake. I wish you all the best. God bless you.